Welcome back. This is Mr. Greenstein's Geometry. We're in section 5.7, using congruent triangles to solve problems. So let's take a look at a map, and this is Route 280 and Route 85 in the lower left-hand corner. And hopefully you can recognize some of this. Some of you are going to recognize it right away. But this actually over here is Homestead High School. And over here is our side of the highway, and Monte Vista is way down the left behind. But the reason why I'm showing you this is because right next to Homestead High School is what was supposed to be a continuation of the road, and then it was supposed to go over 280 and then continue down here. This is Mary Avenue on both sides. Well, back in the 1960s, they ran out of money, so they couldn't complete this, and what they did was they built these ramps on both sides for the bridge, but they never connected up the bridge, and after that, nobody really wanted to put a car bridge there. But they did want to put a pedestrian and bicycle bridge across there. So that had been talked about for years and years and years. So this is one of those problems where you have an active freeway here in the way of something that you want to put up, and you like to get the measure of this without having to walk across the highway like that. And this is very similar to problems that they tried to solve years ago, thousands of years ago, where they were trying to get across rivers, and they didn't have a way of like walking across the river. They wanted to find a nice narrow place. So let's just take a look at this and zoom in. And when we zoom in, we can do a couple things. One is that we can put a flag over here on this earthen ramp here. And we can go over here and put a flag where we want to land the other side. And by using some crude tools, we can create a 90-degree angle and measure 400 feet going this way. Then measure another 400 feet going straight, a right angle, and right here at this point we're going to put another flag. So we're going to walk from this point in this 90-degree angle until we see the two flags lining up, and then we'll put a flag there. And we measure the distance from here to here. So now we have these two triangles. On this side we can measure each one of these, no problem. On this side we can measure this one, but we couldn't measure these other two because of going across the freeway. So in this chapter we can show that two triangles are congruent. If we can prove they're congruent, then all the corresponding sides are going to be congruent and all the angles are going to be congruent. And we call this corresponding parts of congruent triangles are congruent, or CPCTC. You should commit this to memory. This is very, very important. So let's just go back, and we can see here that we have an angle, a side, and an angle, and over here we have an angle, a side, and an angle, and that's all we need to show that these two triangles are congruent. So let's take a look at a problem here with this figure. We know that we have WO is congruent to OZ, or ZO, and we know that XO is congruent to YO. So we want to show that the third angle here is congruent to this, or this angle is congruent to that angle. W is congruent to Z. So the first thing we do, we state the given, and then we say, well, we have vertical angles, and the vertical angles are this angle is congruent to this angle. Once we have that, we have side angle side, and we've shown that the two triangles are now congruent. Once we know both triangles are congruent, then we can say any of their parts, corresponding parts, are congruent. So we can say that angle W is congruent to angle Z. And that's by corresponding parts of congruent triangles are congruent, CPCTC. Now let's look at something a little bit more complicated. What if we want to prove that this large triangle PTU is congruent to UQP, this other big triangle? Well, to do that, we're going to have some plan. The first thing we're going to do is we're going to show that TRU is congruent to QSP. And we can do that through HL, hypotenuse leg theorem. And we can show that these two triangles are congruent. This triangle is congruent to this triangle by HL. And once we have that, then we know that this side is congruent to this side because of corresponding parts of congruent triangles are congruent. So now we have those two that are the same. So we have this congruent to this. Now we can go about trying to show that TPR or TRP, which is this triangle, is congruent to this triangle over here. And once we have that, then we can do that through SAS. Once we have that, then we have these two sides are congruent because corresponding parts are congruent. And once we have those two sides are congruent, then this is congruent to this. We know that this is congruent to this, and we have this part here, which is the reflexive. Then we can show that side, 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 the two triangles are congruent. Let's just cycle back to that original problem that I was talking to you about. This is actually the bridge that was created at that point over the freeway, and you can go there and visit it now. I hope you go and see it because it's a very beautiful bridge, and it was all done through geometry. We'll discuss the rest of this in the next class.